Let's get started. Um, so we got an intro to Spark streaming, and so let me sort of march you through a little bit of this magic that's happening down the road. So we have this notebook. You don't have to run any cells here. Just so this is extended Spark streaming Twitter utils. It's part of Project MEP. So I'm with Ivan Sadakov, as engineer in New Zealand, data engineer. So yeah, what we are calling here is this Twitter 4J library, which I'll show you how to import that. And then it sets up a Twitter receiver stream by having this class, which extends this receiver class, just like we did with the dummy example, right? But then it has a lot more arguments, right? There is a Twitter auth credentials, and it has filters, which is a sequence of strings. These are just keyword-based filters. And then user filters, which are a sequence of longs, integer long ID for the usernames in Twitter, user IDs in Twitter. Okay, yeah, I think the main thing is, we haven't had the gas to go much deeper in figuring out how to do all the geo scrubbing of geo-enabled tweets, and it's doable. So it's expandable in many directions, but we're mostly focused on users and strings in the streams. Yeah, it sets input streams, and in the end, we can execute this whole notebook from downstream, and it will set up everything we need to start a streaming job. Okay. This one is this TTTDF, tweet transmission tree function. So it creates these, the sort of Spark SQL tweet anatomy and transmission tree structures. So these are, and then there are so useful helper functions. So it reads from Parquet file and converts that to a data frame. And then there is this tweets JSON string data frame to tweets data frame is another function, and then there are a few helper functions. But the way, so this tweets df to TTTDF, this is the main function that takes as input a data frame of tweet as JSON strings, and then it returns a data frame, and then it uses this huge Spark SQL statement in Scala. So it selects various fields, and which are only a subset of all the fields in your JSON string of the status update or the tweet, and then it creates new columns called the tweet type. So the tweet type is the so there's a lot of logic behind what we each column being null and ID and reply being -1. So you really have to design it. It's literally weeks of my time spent on figuring out Twitter API. And I think it still makes sense. But the nice thing is, because we store all the raw tweets as JSON strings in this Google Parquet format, it's a very simple way to deal with the evolvable schemas in Twitter, right? So I think I've seen new JSON fields popping up that says this user has a right to be forgotten since such and such a date. Don't quote me on this, but I think all Twitter does is actually just notifies the developers that this has been. I may be dreaming about it, but I think that's true. So all the raw stuff is there. So it's up to you as a developer to be careful about the Twitter developer rules, and these agreements ensure that you are responsible for respecting the laws of the land you're operating on, right? So it's very different if you're in Saudi Arabia or Singapore or Sweden or India or wherever, right? And I don't want to trivialize it, but the enforceability of the law is not a trivial problem. I mean, for technical reasons, that's down the road, right? So anyway, and then this one is mostly done for Joachim Johansson's project and Mariama's. So here it's just the same thing, but it also captures the URL entities and the hashtag entities in this data frame. So you can start chasing, what's in the URLs that are being retweeted and stuff like that. So again, we will call this function in a sec. So this one, yeah, maybe we should start here, right? Maybe this is the simplest one. I hope it'll just work. So you guys have your 4. Let me think. Okay, let me come back to this just because we're still calibrating with all of what can and can't do yet. So let's start with this. This is the original plan. So we're going to create our tweet collector. Okay. So this is going to capture live tweets and from the public Twitter stream and write to the Databricks file system as a JSON string in a very boilerplate way so you can understand all the components that are being slapped together here. So what we want to do is first install the following libraries. JSON is Google's JSON library, and then Twitter4j minus examples. How do you install libraries? So you can go to, I usually put my libraries in the shared folder. So you can go here, and then you can create, so here's the library we want to install, Twitter4j minus examples minus 4.06. So I kind of want you guys to do this the harder way, or the more exhaustive way. So you do create and library, and then you should get it a window like this. So now what you want is the source. So you can also upload your own packaged jars, assemblies, which we will do for the geospatial module because the libraries we need are too bleeding edge. They're not in Maven Central, which is this repository of all these libraries for Java. So yeah, and the same with our library, you can upload directly, but we're going to go to Maven coordinates. Okay, so this is sort of a central place where mature projects are available. So what we are going to do is search Spark and Maven packages. So this, let me see. So you can actually type here Twitter4j examples. Let's see what happens. Twitter4j. Yeah. So you can just copy paste that, but let's try. So if you try this, do you get anything like this? org.twitter4j, Twitter4j 4.06. Then just choose that. Is everyone able to get that? Okay. Okay, so maybe we should just search here. So if you search here, change this to Maven Central, and then go here and type Twitter4j and enter.
I don't find it in there either.
So you have to change this to Maven Central. You did that.
Sorry? Oh, which domain?
Not Spark packages.
Yeah, it's in Maven Central, yes, but it doesn't find anything.
Yes.
Yes?
So it's all on the board here. Yeah, not Spark packages. Yeah,
sorry.
It's okay.
I thought I had already changed it.
4J.
Twitter is not.
Yeah, that's earlier. Yeah, earlier. Yeah, no, that's So is anyone having trouble? So what we want is a Twitter4j minus examples, because there's a whole bunch of stuff bundled. So don't just get Twitter4j. Where's that? Oh yeah, here. So just grab this guy. You want to hit the select button after. Okay. Twitter4j minus examples. Let's just take the latest, and then you hit this. Okay, and then you'll. So it'll create like a library for you, and then you say, I don't want to do it because I already have it, and then you have to just follow the online instructions and say install a library. Yeah. Which one? Oh yeah, you got it. Yeah, there you go. You hit the select button.
Which one?
Right here, and then say create library. And so now you see, once you create a library, it'll give you all these artifacts and dependencies. And then leave the option attach automatically to all clusters. Leave that option ticked, and then just attach or whatever. It says okay. Good. Yeah, that's it. Yeah, that's it. It's good. Nothing more. Now we go back. We need one more library. So this one is JSON. Try and search here. Yeah, so this again you have to change this to Maven Central. So Maven Central is more general. So this is the Google JSON library. I don't know which, let's see, Google, this is com.google, is this the official one? I think so. Yeah. I mean, because different people are giving their own, JSONs, I would just go with the Google one, and then you do the same, just hit the select button.
Is it the com.google.com?
Yeah, so yeah, I think so. Okay, and load the library attached to all clusters. And so now you see, if you go to your clusters, yeah. Whatever the default one.
It's the one from Google code.
Yeah, com.google.com. Yeah, because you see, it's sort of organized by the commercial enterprises in operation that are maintaining these Maven coordinates. So often they maintain different coordinates for the same library. So here is, so I mean, this is the academic shot, so it's got a lot of libraries, but you can do deep learning here as well and stuff. But so here is, yeah, you should see JSON. I'm using 2.7, but it shouldn't matter. And then I'm Twitter4j examples 4.06 is what I'm using. Okay. So does everyone have 4.06? Okay, that's good. Because there are version-specific nightmares you don't want to descend there. And I'm using JSON 2.7. What are you guys using? Okay, so it should work, but let's worry about that if you have problems. Okay. So now what you want to do is, so you want to detach and reattach the notebook, right? Because the libraries that were loaded will not be visible typically to the notebook. So you may want to detach your notebook if it's already attached to your cluster, and then reattach it. Okay, so okay. Let's see. So then, so now we can run this command. Is everyone here? Detached, reattached. It's okay. Let's run this command. Okay, so it ran, and it's basically just spitting out that notebook at you, right, in the output cell. Okay, so now we know there are no streaming jobs running. So, but please go to the cluster, and because I don't know if everyone turned off their streaming job that was running earlier. You're supposed to. So, do you see a streaming tab here in the user interface? So everyone doesn't see a streaming tab, right? Good. So then let's okay. So anyway, you can hit this if it's running. So I'm going to create an output directory root where I'm going to sort of store my tweets, stream, and temp. So I'll probably delete this later because it's going to collect a lot. And yeah. And you know your Databricks Community Edition has limited space. So you have these libraries attached. So that depends on whether you put this in the right place. Where did you upload all of this? Okay.
So what do you do? I put it in share.
Yes.
Use a share.
No, not the library. No, you mislabeled the directory. You put capital S for Scalable. Remember, I said all lowercase. It's case sensitive. So rename it to lowercase Scalable data science. I mean, whatever I said, lowercase Scalable minus data minus science. Yeah, let's please stop me because it's important, everyone.
I just created my new account for Twitter, so.
Okay, so what you do is so
I can upload the
yeah, you did this correct, and then you need the libraries, right?
Yeah,
The libraries. Yeah. No. So you haven't done the library, right?
Exactly. So I got these like four.
Okay, that's different. That's just how you use.
Oh, okay.
You miss the libraries.
Yes, exactly like this.
So then what you want is to go to share. So can the neighbors help one another so we kind of do parallel processing? Someone can share libraries. And then just go to make them coordinates. And then use try to just search our packages. And then type Twitter 4J. And then change this to Maven's like 4J.
Ah, okay.
And then type
Oh,
supposed to do that before. Yeah, Twitter 4J.
yeah.
Yeah, and now you just examples, just select that, and then create libraries. Yeah, so it'll take a while. The other thing you want is the same steps, but JSON like JSON.
Okay, so do the same thing.
Yeah, so yeah, so it's done. So leave it like this, and automatically match all the So go back to workspace. Share and create the library. And then you just go to search. Change this first. Yeah, it's always GSY. No, G, just word.
What is that? Oh. So
Google's JSON. Yeah, now
I'm sure that that's pretty great. Nice. Is everyone okay?
Okay, so I mean, this is just a step, you know. You know, I'm just removing recursively anything that may already be there. And we will want to do that at the very end of this notebook so we don't have all those global tweets occupying space unnecessarily. So here is the slide interval. Remember, we had it 1 second. So this is, the native units is in milliseconds. So I'm just going to say 1 times 1000 milliseconds is 1 second. So that's my duration for the slide interval. Right?
We have changed to.
Huh?
We should change from 1 second to 5 or 10.
We just do whatever is there. I just want to make sure. Yeah, I'm just saying it's 1 second interval, but it's in units of milliseconds. So I have this 1 multiplied by 1000. Because remember from the previous baby hello world example, we used the second method, right? We said second of 1. But I don't want to do that here because I want you to show that the native input is a millisecond level operation. So anyway, so that's our slide interval. There's really nothing to change here, right? Because there's a lot going on. I just want to make sure you can do it. And then, so we have our discrete streams. That's what we're going to do. Except now every second, we're going to try and tap into the... So this import statement must now work for everyone. Does it work? Have you caught up? Okay. So did you detach and reattach the notebook?
I'll try that.
Okay, good. Because if you don't detach and reattach the notebook, it's going to be some really strange behavior. Okay, good. So now we're going to create the Spark streaming context, just like the baby example, right? So we take the Spark context as input to the streaming context and give it the slide interval. That's the only arguments we need for creating the Spark streaming context. So now it's ready to chop things that are coming at it in units of 1 second. All right, this is sort of my disclaimer, you know. I've already told you need to read stuff because this is, you are the developer. I guess in the EU terminology, you become the data controller now, right? So enjoy controlling data, you know. So here is, so these are the 4 things we are supposed to grab, right? The consumer key, consumer secret, access token, and access token secret. And you enter them in the cell below. So let me see if this will work for me. I don't know. So I've kind of hidden my own Twitter credentials in another notebook that you can't see because I'm in a different shard. But maybe we busted. I'm going to use yours as a backup first. You may have to just... But this won't work for you guys, okay? So just don't worry. Sorry, what? Oh, yeah, I know. That's the experiment I'm doing live. I will go revoke it, you know.
It says this notebook is not found for the...
Yes, don't evaluate that. Okay, so maybe... So yours is here, guys. So like you uncomment this. It says put your own Twitter develop. I did it for myself because I kind of... So you uncomment that block, and you know where it says XXX, the 4 X's, put your 4 IDs there. Yeah, just take your time and make sure that you copy paste it correctly. Replace these 4 things exist. So let me know when you guys are ready. I'm just trying to see what's happening with my. Yeah, I think mine probably I revoked it at one point. So, and if you follow the next set of cells and slowly read it, please, you should be able to start a streaming job running for you, right? And I'm just going to have some fun on my own for a second. So I just grabbed. I just grabbed the credentials and put it there as a backup. Right. So when I'm done, you can revoke yours and restart it.
Yeah, sure.
So then don't run the job at the same time.
All right.
Or just make. Sorry, I was going to put my other backup ones, but I forgot. So, because we can't both run streaming jobs with the same credentials.
Yeah.
But we should revoke this anyway after the lecture. Yeah, it's just yeah, because I just okay. So the way I'm doing this also may be interesting, right? So I have another directory called secrets. Okay. So I'm going to sort of directly expose this and then we'll revoke this later. So my streaming collector, I believe, isn't working because I revoked those credentials when I finished the lecture last semester. Is it working for other people? The streaming jobs, you're seeing something being captured when you go to the streaming.
There is a problem in command 20.
Okay, so let me, yeah, so let me,
Yes, it's working for me.
okay, great. So let me just fix myself first. So, you know, I have like bad credentials, so I have to first stop my streaming context. Yeah. Yeah. Yeah, I'll come to you in one sec. I just want to fix my own credentials first. Yeah, and this is. Okay, so yay, I got 88. Okay. So raise your hand if you're, you know, stuck somewhere. So you didn't copy paste these, no?
No, exactly, but I just like got it off.
So you want to go to apps.twitter.com. Just go to https/apps.
I think I got it.
Yeah.
But yeah, I still lost my name.
Yeah, what I would do is go back to the Twitter API, the instructions are to copy paste the script into a notepad. Don't create one. Yeah, just go to
Because I already got one.
Yeah, you have those 4 strings copied somewhere.
Now it should be here.
Yeah, there you go. Go there. So, I mean, it's just safe to, you know, there's so many networks.
Yeah.
It can be online forever. So, I mean, I would just copy paste those 4 strings.
Yeah, that makes sense.
And then, I guess, you know, we're, you know,
It should start streaming after here.
right, so you put all of this in, do it, and you put it all in the right order.
Oh,
Consumer key, consumer secret.
Yeah. Otherwise, you wouldn't have a okay now.
Right, so you, oh yeah, so, I mean, you know, this is, if you copy paste the wrong thing, we'll be sending here for 20 minutes. Right? I don't know, I'm just saying. You know, so I am showing what I'm.
It never validates, right? There's no validation.
No. So that part.
But you should see it when you do it.
No, it won't validate. You will just get 0, and the stream will run.
But if the stream is running,
No, not Spark UI. Oh, yeah, stream. It's not running. You haven't started it. Did you do the ssc.start?
no.
Okay, well then you
I'm
have to start.
I'm not sure how I started. I thought I was starting it.
All right, so let me continue there. So I think maybe all right. I basically, you know, wanted to see if my old credentials were there, and I'm sort of doing a lot of experiment. So you know, once you guys fill out your stuff, you know, you setting this authorization thing for Twitter, and then you evaluate the cell, right? So you have your authorization object, and then you have your Twitter stream. It hasn't started anything. You're just creating this stream thing. So this should finish and give you something like this. And then, so is everyone there? You got the 4 strings in?
yeah, I got them like up here, but I'm still not sure what I'm saying.
But I'm sure it'll work for you, you know. So well, let's not worry about everyone's bandwidth and wireless, because then we will get nowhere, right? So I'm going to try to get to latent directly allocation by the end of today. All of this will work, and I'm happy to sit with you. We can even go to a pub and continue doing this. Right? I have a lot of budget for drinking. So anyway, let me just get back into the mechanics here, right? So what is JSON? This is JavaScript Object Notation, right? And so it's a nice way to represent elements without having to reference to any global indices. So everything is in place in one string. You know, the key, the value. So it's a very nice way of communicating objects as strings. Okay, so that's what we're basically doing here. What we're doing is, so remember, we take this, which we haven't run yet, we haven't started yet, but the Twitter stream that we constructed above is being mapped as follows. We take whatever comes in, X, right? This is the raw thing from Twitter, and then we do this closure on it. So we instantiate a Google JSON object. JSON is just Google's JavaScript object notation thingy, right? It's a slight variant. So I first do this. It's just a constructor, and then I take this JSON and then I convert the X into JSON, right? So I call this toJSON method on this string, and then so this takes care of serialization and deserialization issues. It's not the most efficient thing, but it's fine for us. Okay, and then it returns this Google JSON string basically. So what that means is this thing that's coming at you in Twitter in its own native format is now converted to a Google JSON string. That's all that is doing. So Twitter stream JSON converts Twitter stream to JSON strings. And then I am doing this. I want the number of tweets collected to be set at 0L, so the long integer 0. And then the partitions in each interval, I want this to be 1. Because this tells that the number of partitions in each RDD of tweets in the D stream, I want it to be 1, because I want to be able to write, you'll see, everything that comes in one time block into a file or into somewhere. So these are 2 parameters. Control, and then I take my Twitter stream JSON that's coming at me, as discrete RDDs, and then for each RDD, I do this loop, right? So this loop ends here. What am I doing? What's coming at me in a D stream is actually the RDD and the time, okay, the timestamp or the time unit. And then for each of that tuple, I map it into this this closure here, right? So what am I doing? I do my count, and I count how many elements are in the RDD. So how many tweets am I getting in that discrete chunk of time? And then if count is more than 0, if there's at least one tweet, then I'm saying output RDD is my RDD that came in that discrete stream. And then I'm using this method called repartition, which we haven't seen before. It just simply repartitions, you know, the RDD, because the default thing in the community edition is something by, you know, some number. I want it to actually be 1. So why I want it to be 1 is because I want the repartitioned RDD to be in one file, one part, okay? Because I know it's not going to be too big. There'll be at most maybe, you know, 90 to 120 tweets per second. We'll see. But I know this will work. So it's not good engineering practice, but it's good enough for us. So then once I've repartitioned it, that's my output RDD. You see, I can just use the save as text file method, which will now write that single partition to this output directory, the root directory we had. And then I'm just concatenating the subdirectory called tweets underscore, and then I'm putting the time milliseconds into a string. So I have a way of nicely, labeling the directory that all the tweets in that time interval in the beginning millisecond goes into. So this is just a convention for time-stamped directories where we dump stuff in. And then I simply increment this num tweets collect, which is a var, so I know how many tweets are being collected. Okay, that's all. That's it. And then you have to hit this ssc.start button to actually start the streaming job after you've executed the cells above in order. And then just give it a few seconds and then hit this, and you should see the number of tweets collected to be some number, right? So now I've already collected 20,620 tweets from the public stream, right? I had 88 in the first couple seconds. So you will have around something more than 0. And that, this is just a running count of what we're collecting. So if you go to the clusters and go to the Spark UI, after you have done the ssc.start, there will be the streaming thing, and then you should start saying, oh, look, there was a little spike here. Some event happened, which led to 300 tweets per second, right? This is like basic operations. I don't know what's going on there, but you can do all sorts of things downstream. We will get into to figure out maybe what's happening there. Okay. So then what I suggest is if you've sort of collected, we're getting ahead of ourselves. So that's tapping into the global free public streaming API. So you don't want to do this for a long time because you'll just kind of run out of space. So yeah, so it keeps increasing, right? So then you want to do this, okay? ssc.stop spark context equals false. So that means stop the Spark streaming context without stopping the Spark context that it's coming out of. So we'll still have our Spark context that we're in. So we just drop out into the Spark context. So that's why this argument false. So now our streaming job would have finished. So if we go back to clusters and then look at the Spark UI and see, I see no tab for streaming anymore because I stopped the Spark streaming context. Okay, so now that you've stopped it, it's not going to keep collecting data, which is good. You don't have to delete it. You can play around with that file that you collected or restart it later. Let's continue with. So is everyone happy with command up to command 35? No, Maria? Oh, you're fine. You're just tired. Okay, so you're okay. You had some problems. Okay, guys. So then we're gonna kind of go fast. Okay, so now you have data, right? So now I'm just basically going to look at what's in there. This is just the dbutils, so what I'm seeing is exactly what I meant to store, right? I have my dbfs path. Remember, I took my root directory, which was temp tweet temp, and then I did this string concatenation of tweets underscore to the millisecond at which I collected it. So that's why it's nicely timestamped. And then the tweets dir. So this is basically, so I have to find the right one because now this was done a while back. So let me look at 152. So a lot of milliseconds have passed, right? We're all getting older. 152.48305.38000. So you need to put in whatever timestamp is there. So this is a specific directory we're going to look into now. You see, just put one of these things. And it says size 0 because it's just the directory size is 0, but there's contents in there. So now I'm just displaying the contents of that particular directory, and you start seeing this success, underscore success. So this is like the distributed file system. When it successfully writes into that directory, it'll put this underscore success thing. And then the part minus 000 is the first part of that the distributed file system. And because we said repartition 1, it's pooled everything together, not used the default partition for RDB, and made it into one part. And I kind of wanted it because then it's easier. And the size is quite big, so this is in bytes, I guess. So now I can basically do part just run this command. Then I will get 52. There are 52 events in that second, right? So this means roughly 1% of all the tweets is the maximum you can get in this thing. And I'm guessing, in that second, this is some sample, according to Twitter's proprietary sampling rule, supposedly random sample of the global tweets, okay? And I don't think we'll all get the same number or this exact same events, and that's kind of a different story. Okay, so now I'm basically using SQL context to read the JSON, because I know this is JSON, right? I wrote them as JSON strings. So I can just use this read JSON method and directly read it. And I can print the schema. So what's happening here is when I say Spark SQL read JSON, and I'm pointing it to a whole directory full of lots of JSON files, right? The Spark SQL context does a double read, basically. Reads it twice because I don't specify the schema. I'm automatically inferring the schema using Spark SQL methods. So it's kind of not very efficient if you know the schema of what's coming at you. But Twitter, as I said, can introduce new keys and values in its JSON, in its status update, like when law changes or whatever. So that means if you can't really expect to have a fixed schema into the future, right? Or the schema itself changes. So I'm not like a database guy, but I played around a lot with it, and my final solution is this. I just take the JSON string of the raw tweet object, and then I store it as a single column Parquet file. This way, if I want to read any time interval in the future for exploratory analysis, I can just say read from this time to this time, and I'll just use a Spark machinery. In the worst case, I spend 2 times as much time reading it twice, right? Because once infer the schema of that time interval. So that way, I'll always be, schema independent. Whatever is there, I will get it. The union of all the keys and values, I will get it. Okay. Yeah, I mean, Ivan, this guy knows a lot more. He thinks he can do this at a binary level and stuff. But no, yeah, if you start a company, yeah, that's a good idea. So, so that's my schema, and you can see there's quite a lot of fields. So we start from the root. It's kind of a tree-based structure, right? So you have contributor IDs, which is an array that's nullable, and element string created at string, the date, when was the user created, hashtag entities, IDs. So it's quite a lot of fields, right? Is favorited, is possibly sensitive. I don't know. Please, geotags. I was going to do geotags, but I think if you descend into the Twitter rules, there are explicit instructions on like being very, very, on behavioral profiling based on geolocated tweets. Like, so I kind of, well, we can do it with the methodologies you'll learn, but I'm not probably going to combine the geospatial modules with the actual Twitter stuff, because that's getting very close to, yeah. But you can do it on your own as your own data controller. So here's an example. So I'm just picking up ID and text, and then simply showing it using false. False just means show everything. Don't just make it into a pretty table, ... So I don't know. So a craft beer festival in Chelmsford this weekend, and another in Colchester next weekend. I don't know. Truly an age of wonders in which we live. Some ASCII Chinese or Korean characters coming at you. Okay, and there's like people tweeting URLs directly in the text. Okay, so it's there's a lot going on. Okay, Nagalipatnam, Patan. Okay, that sounds very Indian. No, it's not. Toxic. I have no idea what language this is. Nagalipatan Nasa Twitter Yungma toxic suffix. I have no idea. Anyway, do you see anything Japanese here?
Yeah.
This is Japanese? Ah. Do you know what it says? S Toribus. Anyway, it says something. All right, so let's continue. So you can also use Databricks' display, which is quite convenient because it's a lot nicer to navigate. And then it's just seeing the same content like this. Okay, so you just sort of move around, and it's a bit easier than just .show. Now let's be good at housekeeping and clean up the necessary data in the DBFS, right? Because I kind of want to, clear things when I'm done, and of course you don't have to. You can play around with the things you collected later on the train ride or whatever. Yeah, wireless. Okay, so there's a lot we can do. So there's a new Spark library for natural language processing that I have bookmarked, but haven't really descended into yet, I believe. I'll share it with you guys at some point. Oh yeah, here it is. Introducing the natural language processing library for Apache Spark. It's it's from John Snow Labs. So there's this tokenizer, normalizer, stemmer, lemmatizer, entity extractor, data extractor, part of speech tagger, named entity recognition, sentence boundary detection, sentiment analysis, spell checker. All those things are kind of naturally combined with Spark's MLlib, which does topic modeling, word to vec, term frequency, inverse document frequency, n-grams. If you don't understand these words, don't worry. You can descend into them, but it's heavily related to what Simon was talking about. Right. So all of this that Simon was doing, you can do completely at scale here. And also just by doing training and testing and cross-validation, you essentially have a very formal predictive model, at least. Okay, so now we so let's see. Okay, I guess we did the boilerplate thing, so now I'm kind of trying to do it a little cleanly, right? So is everyone okay up to here? You were able to stream. Awesome, you got it caught up. Awesome. So now I'm going to sort of slightly take you to like a little bit better software engineering practice, I think. Let's throw the bits and bobs of code above into a function called streamfunc for simplicity and modularity. I mean, I'm not saying this is the right way to code or learn. This is how I learned to do this. So I'm just showing you, right? And then, so what I've done now, I just have the same things, the library imports I need, and then I have output directory, batch interval, timeout job length, new context created, all of the same exact stuff that we did before. Now nicely thrown into this function with the authorizations and the tourist streams all done in place. And it takes care of this partition each interval, one. And then I'm doing my for each RDD. And exactly the same thing we did before. Right now I'm doing slightly more stuff. So now I'm saying I want to write by year, month, day, and hour. And then in that hour directory, I want to write 5 milliseconds or whatever my time interval resolution is. Okay? So when I collect action in New Zealand or somewhere in South Pacific, my RDDs are like 10 minutes because there's not a lot of action. So I want to write enough stuff. Remember the small files problem. If we took a while to load this State of the Union addresses into the DBFS, right? Because you don't want the file to be too small, because then the metadata to store the file information and the distributed file store becomes too big. So you want it to be at least, the bigger the better in some sense, because then it'll automatically break it optimally. So you may have to play with the size of the time interval and whether you're partitioning into one or whatever. So I do partition by one because I want to write them to the specific year, month, day, hour formatted directory structures, because it'll allow me to use more elementary operations to directly read time indices. So if I have some other data store, so this is one way to do it, right? Of course, if you have access to something like Cassandra, which is another key value store, there's a lot more you can do. But we're just using S3 on DBFS. What else am I doing? So I write save mode append. This is slightly different, right? And then I write Parquet files into this output directory. So I do save mode append because I want to append to I want to append to that particular string to completion. So now this is a lot cleaner, less boilerplate, and because I'm using Parquet, I get this nice compression of the strings, and so once again I can define my Spark streaming context and start it. Right. So don't hit this right away. So it's so let's just go to the clusters, because that'll stop the thing you just started. And let's look at Spark UI. And this is the new streaming job. I've started with this nice functional one. So one was completed. 429 records were observed, right? And so it's 1 minute, so I have to wait at least a minute before I refresh the streaming to see some action in terms of plots. So is everyone able to do this in a more functional way, so you don't have all the boilerplate code running around? So it's just that one cell now you can take. Okay, good. And essentially, that's kind of what we're running here for the Swedish election data. It's just the next notebook, actually. Okay, so yeah, you see, after 2 minutes, I can start seeing some kind of curve here. So I already have 3,180 records. So It's almost the next one. Yeah, I really need to open 2 tabs. Okay, so I'm going to stop mine. I think I have enough data, and now I'm just sort of looking into this directory, right? So this is my tweet stream temp, and of course the year is 2008, and then I have to change this because 2017 was last year. So and I don't know where I want to get into, so I'm going to just go 1 level deeper, and then of course it's April still, and should be the 27th after that, right? The 27th. So I'm just descending, and it's apparently 12 hours is 12. It's probably Oregon time. What time is it in Oregon? US West Coast. Oh, I have no idea. 12. Oh, it's using British Standard Time. Sorry, UTC. Anyway, it's the clock of that thing, right? So you can set the local clock if you want. So, and then of course, you know, my 2 minutes I collected is just putting the milliseconds timestamp at the beginning of that. And of course, you can do all the same things. You can now take a peek at this. So let's do that. So for this, we're going to use this function, right? 025_b. TTTDF function. So this is the other thing that's going to take our Google JSON string and automatically create data frames and tweet transmission trees for us. Thanks for coming from far away land, Romeo. Yeah, so did you guys think Simon did a good job yesterday? Yeah, so yeah. I thought so. I really enjoyed it. So let's yeah. So if you run this, it should execute, and you will get all of this tweet transmission tree functions defined, right? So let's not get into the logic of that. You can knock yourself out later. So what I'm going to do is change this to 2018, and it's April, and then I put this for yeah, 27th hour, and then these stars you need, I think, because it needs to descend to the right level of the directory. So this should all work by just changing this to 2018-04. So I've created this raw data frame, which is simply from Parquet file to data frame thing, right? So it literally reads in the full JSON and throws the entire you know, live dynamically inferred schema and creates a whole bunch of columns for you. And then the next one, you know, basically takes this raw data frame, which is from this step, and then it does this tweets JSON string data frame to tweets data frame conversion, and then the tweets data frame to this more mathematically relatively tractable object called tweet transmission tree data frame. So this is what we want to do, and I can ask what is TTT's DF count. So I have 3,180 tweets in a couple minutes from the public streams, and then I can ask to display what it has. So I'm just picking up only a few of the elements, right? So it has a whole bunch of stuff, right? So the current tweet date. So current tweet ID, this is very special. This is essentially how you can go and grab the tweet retrospectively in Twitter. So when you say, you know, don't track my tweets, then don't tweet, because tweet by definition is a public post. So which means if you have this Twitter ID, this is how, like, you know, when I submitted this paper, I give them the entire 27.4 million tweet IDs. That's legal. I can do that. And anyone that has a little computer at home and electricity can actually go and grab all of this. Twitter does have API rate limits, so you can't get it all instantly, right? But you can get it all. You know, in a couple of days you can get it all. It's just this laptop running, you know. So then why is that? Because it's a reproducible experiment, right? They can take all of this and try to show that I'm somewhere I went wrong, right? For example. So this is very important. And then the other stuff you have are, there's a lot of these fields are nullable, so they have null values. The C post user ID, O post user ID, and RT. So this means original post user's ID in the retweet. And of course, this is only sensible if it was a retweet. So this is where all the logic of SQL is important. So we go to this one of these last columns called tweet type. This is an original tweet, so it doesn't, tweeter and the retweeter doesn't apply. This is a coded tweet, and this is the mention type is a coded mention, and this research assistant Akinwanda Tende, this Nigerian Kiwi guy, he did a lot of this SQL logic, and he is so the way we checked all of this a while back, it's just in the original MEP notebook, is we just had Twitter accounts between him, me, my daughters, and so we did various explicit things. We code tweeted, reply tweeted, and made sure that everything was captured in this. So it's not like, it's not like rigorous, but we can change all the logic easily. Okay, so now I can display and group by tweet type and count and order by the count in descending order. So in this particular 2 minutes, my retweets were 14,096 and my original tweets were 917 and so on, right? So I can just do some kind of bar chart quickly and kind of expand this, be a bit lazy. Then I can basically get one of my pictures I showed in the slide, right? So you can always go back to the stable, and remember you can always download as CSV as well if you want to. Okay, so then I'm going to make sure, because I'm a bit paranoid, I want to make sure I've stopped everything. I already did, but so then I'm going to just be a good housekeeper and clean all this stuff, because I don't really want it to, unless you want to. Okay, so next, let's write the tweets into a scalable commercial cloud storage system, because, well, you guys can't do this experiment for much longer than a couple hours, right? With Databricks Community Edition. Of course, if you're a really good hacker, you can write some really nice scripts to randomize mouse movements and make sure Databricks thinks that you're operating. But I'm sure they're clever. I'll find out. You'll stick out as an anomaly, right? It depends on your resources, but you can actually set up a collector in Databricks. It's pretty nice little thing. And then, but the problem is you'll run out of disk space in Databricks, right? So even if you run this collector in his office, like Simon is doing, you've got a Linux server. Okay, you can have 10 machines, 100 machines. Even the biggest VR grants are not going to get you all this. And with GDPR, I'm sure there's issues with putting it in the Swedish National Infrastructure for Cloud Computing, right? So if you want to be an independent researcher, is that what the right term is, Amelia? An independent citizen researcher, citizen act, whatever, citizen scientist.
A journalist.
A journalist, yeah. I guess I'm a mathematical journalist, right? So then you really need to put it somewhere, and you need to put it in a cheap, scalable storage with encryption guarantees provided by someone like AWS or Google, right? Because then you can kind of say, well, you said it's encrypted, but if somebody takes over that encrypted stuff I paid for, then it's not my problem, right? You see what I mean? Anyway, that's a different story. I really don't know how all of this, but I think the syntax you need. So to get Amazon S3 is this simple storage service. That's really what's underneath the DBFS, Databricks File System. Then this is one way to go. Of course, you can do this in Google, and you're the expert man, right? So you can do this multi-cloud babbling on Kubernetes. So yeah.
Yeah, like
cloud agnostic.
Something called Minion. So you can install
Minion.
it. Yeah.
Nice.
You can install it everywhere, and it gives you the S3 interface.
Okay.
So you can run it even on the Slick cloud.
Oh, okay, yeah. I mean, what I want is like a minion that will babble between like different commercial providers, right? And especially when I'm traveling in air traffic and as I change zones, that would challenge law like crazy. I'm not a security operative, right? That would be cool, right? Because then you have your data in multiple cloud platforms, multiple commercial providers, but then then you kind of couple your physical presence with them. Now it's beer talk. Just poetry right now. So anyway, this is all you have to do. I won't go through this, but you need to have an AWS account, and if you know what this is, all you have to do is put your access key, secret key, encoded secret key, AWS bucket name. Make sure that your AWS bucket is in the same zone as your Databricks operation is. So this is very important, or you're going to just kill yourself. Remember when I started, it said US West 2C, I think that's the Oregon region. So you have to make sure that your S3 buckets are also in that region. So there is 0 bit transfer costs intra-regionally. So if you put your data in like Germany or Sweden, is it already here? Is it an operation in AWS? We're supposed to build 3 data centers in Sweden. So that's why I thought, I had like a whole 50 minutes prepared on this stuff, right? So AWS Sweden, they're supposed to build it. They finished France, I thought. Yeah, launching, coming, Anyway, so I don't know if it's physically there yet. I don't see it in my options to launch stuff yet. So so it matters where you put it. So if your free Databricks Community Edition is running in Oregon and your S3 bucket is like in Germany, then you pay for a huge amount of money for the transactions, which you don't want to do. Besides that, it's pretty much easy. You just mount this S3A access key : blah, blah, blah. And then it becomes like a local file store that you mounted. So you can just see terabytes of data on your little thin weight community edition if you want. Yeah. But probably at that point, if you still want to use Databricks, it's way cheaper to just, you're going to be spending so much time doing admin, it will be way cheaper to just pay some Databricks units. Of course, you can do all this if you have a very tight, secure, if you know what you're doing and you have your own Linux server at home and you can put all the data in AWS or some place. So now let's complicate this a bit, okay, make it more interesting. What did we do before? We just plugged into the Twitter, whatever the public tweet, whatever, 1% at random thing. It comes all languages, I have no idea, right? So what I really want is to now track a list of strings and follow a list of users. So now we're getting into customized experimental designs. So I want to formalize notions like populations of interest, strings of interest, and then I want to, only collect status updates that are either directly by these specific users or related to these specific users. So maybe someone else retweets them or quote tweets them or reply tweets them, or they make their own original tweets. So now I can really zoom in, and if you do this, you can get quite a lot of information on everything, but a lot more because you still have up to 1% of the Googleable tweets. So if you zoom in, you get a lot more of what you really want. So what do we do here? We basically do the same thing. So we run this notebook, right? Which is the same thing we had before, the extended Twitter utils. So let's bring that guy back here. And then we already saw what this tweet transmission tree data frame functions notebook does. So now we have these 2 basic little thingies that are extensions of Twitter4j sitting at us, nicely integrated with Spark streaming library and Spark SQL. So now, yeah, I guess, I'm just always a bit paranoid, so I want to make sure there's nothing running that's already streaming job. And then, so this is my sort of simple way of putting this Twitter credentials. You see, when I'm doing this, I'm not showing you my actual strings, right? But when you guys hit it, you see your actual strings, right? So what I've done is called a lazy definition, right? This is a not a bad idea. And since we're going to revoke these credentials, I'll quickly show you. So in my secrets, this is the notebook I'm calling, right, with that run command. So instead of putting val, I've put def. So I'm sort of lazily defining these variables, and it's exactly everything else is the same. Because I've done def, it's not going to print it out as I instantiate it. So it's kind of nice. So you want to, yeah? Well, not for you, right? Sorry. Okay. So I just said, all right. It's my thing, right? Like, if you want to like sort of make money, teach this class somewhere, take all the notes. I don't care. Please do. But you will work hard. Trust me. When part 2.3, you update all the notes. It's going to be. I will be happy. So I'm just saying. What I'm doing is I have this little notebook that I'm not showing you. But given that I'm going to revoke it, I'll show you what I'm doing so that it's not like a mystery thing. Yeah, so anyway, that's that. Yeah, so let's go to track and follow. I might just kind of go through this bit fast. Okay, so then, so what I'm going to do is, at one point I had this list. I may not run this live, guys, but I had this file store, which had to remember, like if you have a CSV file of users you want to import, okay, remember you can go to, is it data? I think it's data. And then you can say tables. This is one way, it's a GUI way. And then you can say upload file, and then browse. And you say you have a CSV file that's nicely formatted with just the Twitter IDs or whatever of interest. Then you can just hit that, and then it'll give you this particular path where it's uploaded the file. File store tables and some name. So that's basically what I'll copy. And in fact, that's exactly what I've pasted here. So yeah, so you need to basically have some list of users of interest that you can, or you can just type in a short sequence there, right? So and then I'm sort of showing you, yeah. I'm selecting just the first column because I didn't label the columns. And this won't work for you, but and then I'm sort of casting it into a list buffer, and all I have is a mutable list buffer of integer long IDs, which are the user IDs of interest, because that's the input I need into my track and follow method, right? So should we do this? Let's see. Let's just track Trump now, right? I don't know how much time we have. See, we could have a lot of fun, right? But then I won't be able to tell you other things you can do to have fun. So let's see, what do we want? We want a list of longs, right? So let's see, what is Trump's ID? No, so you have to have the actual integer ID. So I've done this for this other one just this morning. So we just grab that from here. Yeah, so real Donald Trump, this is a REST API thing. I haven't shown you guys how to use it yet, but it's 250738777. So come on, Control C. So let's just track and follow. But this is essentially the experiment Joachim was doing around the UK election. What he had is a huge list of journalists and news bloggers and newspapers and MPs, all the members of the British Parliament. That's this huge list, which is a very interesting value, right? That's what this one is. So, so if I just put Control V, and I have to put a capital L because I wanted to infer this to be a oh yeah, so this is Python mania coming at you. Okay, so I created a little thing for just Trump. So this should go forward, right? But just in the interest of time, just look at all I'm doing is I create output directory, batch interval, 1 in minutes, because now I'm actually multiplying by the right number of milliseconds inside that, right? 60 times 1000. Because I want it to be in sort of minutes. And then it's basically exactly the same thing. And because everything is already in the 025A to extended Twitter utils. And yeah, so here's something, SDS rules. So this is this track. So if you guys tweet make data great again, we'll try this live right now. Or SDS 22 rules, whatever, 360 rules. So these are lists I'm going to try to track, okay? And then I already made this simple thing, right? For, yeah, this one is defined. This is just Trump. So I guess this should work.
Sorry, you follow Trump now. You made another list.
Yeah, like look, because I didn't want to follow all this British election, thing. It's already past history. So I thought, okay, Trump is still always active. So I'm going to track Trump. So my list has only one element. So that's the Twitter IDs directly from CSV or whatever. So then I think, because you see, I have these two arguments, right? Track and follow. Twitter IDs directly from CSV has to be some list. So remember, these are arguments. Track and follow are arguments to that extended Twitter utils create stream method in 025A, right? The notebook we just ran. So it should just work, I think. Let's try it. Why not? Okay, so let's see. Okay, it seems to have at least no compile time errors. So then I'm just going to define my Spark streaming context and start it and hope the best. So yeah, so you guys can, if you have on Twitter, we can tweet, right? So I mean, just want to make sure I'm not bullshitting you, right? So you can say whatever, make data great again. I don't know, those strings, because I don't know. It's supposed to work. What was the strings? Hashtag. There you go. So if you have your Twitter accounts, maybe just, @BrowserZone is just my handle. So I'm going to sort of check my Twitter for a few minutes. See, when I said yesterday, like, I don't want to sound crazy, like I had 8 identities, and I'm not bullshitting, right? So because see, we wanted to actually understand what it means to be in an ideological clade of your own, right? So if I have these forests I wrote down, which are talked about, the functions of. So you have your retweet network, right? Your weighted retweet network. These are users. These are users in the leaves. Right, and there are weights. This guy retweets this guy a lot of times, weight 8 and less times, and so on. This is this huge thing, right? It's weighted graph. So this weighted graph, with this geometric Poisson argument and extra, I was able to pull these projections, which are forests. The forest, because there will be isolated trees here that don't talk to each other. But then to really get an idea of whether your algorithm is working, your mathematics makes sense, I really need to understand what's going on in one of these clades, right? So these could be a clade of some extreme ideology. It doesn't have to be a hate group or anything. It could be just people obsessed with some kind of pop music or Star Wars, whatever thing. So then what you have to do is like, because in my actual verified Twitter account, I actually follow so many things, and it's complete crazy. It's like a bot account, right? So what I do is I start looking at feeds, say from Voice of Europe, which has a perspective, and some other thing like some other point of view. There's like Hindu fundamentalists in India, they have another point. So these are, because I was able to take groups for that study. But you can do anything. And then what you do is you start retweeting with a different Twitter account, only tweets of that class. Then Twitter has the standard algorithms that it will recommend people to follow to you. It's just a basic scalable recommendation engine. And you will quickly get absorbed into this world. And the reason I did that is actually, remember Microsoft did this AI study a couple years ago, or 2 times it failed. One time it became a junkie, this bot, and the other time it became some other weird character, right? So it basically gets cornered into one of these little plates, and it can't come out. It loses perspective, basically. It's this kind of. So I think that makes sense, and you can easily lose yourself. If you start only looking at Voice of Europe feeds, you're like, oh my god, look at all these crazy Arab doctors who are abusing whoever, right? That's like 1 or 2 instances amplified, and that's all you see. And so to really appreciate it, I mean, as a proper statistical researcher, my stats researcher, you want to get into each claim. So I was relatively happy with this 1/1 plus number of retweets because it's very simple mathematically, but also these trees it generates. Remember, these trees are generated by the influential nodes of interest. There are landmark nodes you choose, right? And that in turn defines that pairwise distance and all of that. So that's what I meant by, I have 8 identities. Now, of course, I killed all those accounts. That was just to test the math in a hurry. But so did anyone do anything with these words in Twitter? Yeah, because, this is only, a sample, right? So it's not going to necessarily grab everything you did. That's the annoying thing. So let's see what's here. Okay, so we have to descend into this directory. I haven't tweeted anything, so April 27th. Is it 12 still in British? Oh, I'll put stars. Oh. Okay, 12. Okay, so it's a bunch of stuff there. Yeah, well, I'll keep running it, and then let me just, as it's running, I can still read it. Okay, does that look good to me? Okay, so here's my tweet transmission trees data frame. And okay, it's gotten a bunch of stuff. Let's see what's going on. Real Donald Trump was the original poster, right? So he's the man. It's very popular. Hiroyuki Miura is someone who C post username. So this actually is a retweet event because he was the original poster of the retweet Hiroyuki Miura did. And then let's see. She has only 61 followers and 210 friends. She's not a verified account like Simon or myself. She's not geo-enabled. So what's the tweet she retweeted? Please do not forget the great help that my good friend President Xi of China has given to the United States, blah, blah, blah. I mean, it's, it's good. I have no idea where, if any of the strings will be, Trump will swamp us out. But we're supposed to collect the strings as well. It used to work. Let's see. Yeah, I mean, how many people did it? Yeah, 2, yeah, maybe. Anyway, so I mean, this is a sampler, right? Because you have to pay Twitter if you want the exhaustive stuff. So we may not find anything here. But let me move on. So we finish at least this notebook before Fika. Yeah, so let me stop this, and yeah, I'll just get rid of this. Yeah. So are you guys comfortable? So you are now your own data controllers, right? So one thing that's missing still is the REST API design. So I've only done screening for you, right? And remember Simon talked about this Back to the Future machine. That's like mixing REST API. What's REST stand for? What's the acronym for REST? RESTful state transfer or something? Representational state transfer, yeah, thanks. I refuse to use acronyms I don't understand. I don't remember, it's dangerous. So yeah, representational state transfer is another API, application programmer interface, that allows you to, make queries, but it's usually at a rate limited thing. It's not like Spark streaming where you can just start sucking in as much as you want. It's happening in real time. So you have to go back into the past. So this particular notebook, which you kind of slapped together in a big hurry, is essentially how to explore a particular user's timeline. Okay, and so we'll once you have this under your belt, then it'll allow you to go into the historical timelines of any user. So coffee is almost here. So now think of this. It's a bad picture. So think of this as a slice in time, right? Well, this is actually a time interval, right? Because it's a weighted network. So some time interval. We're looking at all the retweets, for example, and so now imagine there are various blocks of time intervals, right, into the past and so on. So now you want to like go into the board, right, back in time for every user. So you may be interested in the influential users or some population of interest or whatever your problem is, and then you can use this REST API to get up to 3,200 status updates in their historical timeline, right? And you can get quite a lot per minute, every 15 minutes. So these are called, retrospective augmentation. So that's what we call them in our design. And so that means you can go back and then ask who are the most influential nodes in each person of interest timeline, and then add them to the streaming API's user IDs, right? So you can do this iterative design. That's exactly what we're doing with video collection. And we, right now it's static, so hopefully Simon left, but what we were discussing over lunch is he's got this nice way of trying to identify influential users in Twitter that are not affiliated with institutions, you know? So these are very, like Tommy Lauren in Texas, right? She's her own woman. So then it'll be important to bring their perspectives into the design, right? And that's kind of the current plan for Swedish election. And then, of course, iterate that every Sunday at midnight, right? So it's a dynamic list. There's no coffee yet. I'm pretty sure I ordered coffee. Are there any questions about the... Yeah?
So if Twitter gives you like 1% of tweets that are coming, how can you track a particular ID? Like just 1% of the tweets is particular ID?
So, I mean, I think a lot of this is mystery to me. I read a lot, but the way I interpret it, and it seems to work the way I interpret it, is, see, if they let you, when we did our screening jobs, we saw that spike, right? It went to some huge number. So I've seen spikes as high as, I don't know, it's usually around, a couple hundred, whatever. So it's 1% of the random sample of all the global tweets in a live stream with some upper bounds. And I think it's also a function of how many people are collecting it. I don't know what's going on, but it's quite a lot of numbers, right? A few hundred per second is maximum if it happens. But then when I do my own custom collector, I'm using Twitter4j. It is all just interfacing to Sparks. All of this is Twitter4j, Java library for Twitter. So the Twitter API allows you to do these extra things, like I'm only using, I can track a specific set of users in a live stream, or keywords, or geolocation. I haven't done that part yet in Spark, but that's enough for me. And so when I put these specific users in, I will get a lot more of their tweets because it's way less than my sort of what I think was a global budget. Like you see what I mean? Which is nice because then it allows you to zoom in. If you know what you were looking for, it allows you to freely zoom in into the streams. But of course, without a historical perspective, it's very difficult to make sense of it because a lot of the network algorithms will not make sense because these will all be tiny little broken components. That's why you go retrospectively augment, do 1-degree expansions, and come back. Then you get pretty much usually a giant component. And when you don't get a giant component, then the random forests that come out take care of the natural fragments, because some people just never communicate with some people. So I think I'll stop the stream.